Our first speaker is Tom Eichhorn. Tom has been part of the networking industry for the last decade or so, and as he tells me, he keeps living on the bleeding edge, and this is what he will be talking about right now. Welcome, Tom.
Hey, folks. So, inventing the wheel. I have a question for you. Who ever reinvented a wheel? Well, it seems at least somebody, but not invented here. But sometimes you come to the situation where you see there is no wheel. There's no solution which fits what you want to do. And sometimes you need to do different approaches. And that's what I want to talk today, how DE-CIX is doing network orchestration in the future. So let's have a look on the agenda. The sun has risen. I would like to talk a little bit where we come from, how the last, let's say, 10 years looked and why it didn't work. Then I will look a little bit forward, what we want to change and how we want to change and why. Then a little bit about implementation, what we learned while trying to do that stuff. And then also testing and all these pesky things you need if you are the biggest internet exchange in the world. Nobody wants to be on the front page of Heise with, "This guy took down the internet." At least that's what I hope. If you want to do that, we have job offerings open. So let's have a look back. 2013, there was a DENOG, and a colleague of mine was showing these slides. It was the invention of what's known as DE-CIX Apollon, our wonderful platform which still survives till today. Well, the world was a little bit different. There were only 2 DE-CIX locations, Frankfurt and New York. There was no global spanning network as we have today, and people planned differently. In 2013, before Apollon, we used scripts together with a database, a file database, like the wipe database, to configure the systems. This was Perl, SET, and AWK. And you could manage a whole internet exchange with that. And yeah, nice thing, but it doesn't scale. Well, when this Alcatel-Lucent platform, known as Apollon, came, and people said, okay, we can't do this with the file database anymore, we can't copy and paste stuff manually, it doesn't make fun. And people saw an opportunity. Alcatel-Lucent at that time had a tool called SAM, the Service Aware Manager. It's a big Java monster, but it could configure the devices. And it had an API to the other side. So people said, okay, we want to make our customer delivery faster. We want to improve the experience. Hey, let's use that tool. And we came up with this design. Well, we have some router somewhere. Who would have guessed? There is this NFMP, which is the new name for this old tool. There's our internal system called CWS, the Central Web Service. And yeah, if you called somebody and you maybe got Gav on the phone or E1, they would say, okay, we can do that stuff for you. They go to this tool called Artemis, our internal tool, and we're doing the configuration stuff. And that was sending some tool calls to CWS. CWS was doing some SOAP calls to NFMP, and that one would then do SNMP calls to the router. Well, it worked, and it still works. But time goes on. This is the current architecture if you would use it as it is today. It has grown. At some point, people asked for a web portal. Hey, we want to do self-service. At some point, we have those finance people. Do you know finance people? They want to have numbers, correct numbers. And there was this big ERP doing crazy stuff, but it wanted to have live data. We went global. It's a funny thing if you look at such a design. At one point, what do you think was a unique identifier for a customer? Of course, we are all peering people. It's the AS number. Well, That was before the globalization. Now, one AS number can be a multitude of companies, and things got more complex. People started to build different tools. You can see here this is called Desire. This was an approach to say, okay, let's reinvent everything. But it never got to full fruition. And it's still for some parts there, for others it's not. And when people came around with such tools like Netbox or Nautobot, well, documentation beforehand was a media wiki. Now we at some point had, okay, we have now some kind of structured data. We all want to integrate that. How can we do that? And when we saw this all and thought, can we do a drop-in for the NSP to get rid of the old part? Or do we want to do more? Do we want to become better? And when we have looked at the architecture you have just seen, and the whole operating support systems, OSS called internally, has organically grown. There have been tools added on, features added on. So if you today order a direct cloud connect, so a connection to a hyperscaler, that is a child of what was VPNI in the early beginning. But it had complete different requirements. Only on the platform, it was some kind of L2 transport. Doesn't work. Also, we have so many systems, and data was being duplicated. We wanted to get away from that. So we saw all of our systems need to be separated for different parts. There's no one system to rule them all, because that doesn't work. Also, we had some organizational changes. In the old world, there was a software team which was doing all the software. There were some network engineers doing the operation stuff. There was a network design team doing the design. And those three groups didn't really play well with each other. So we decided, okay, we want to change that. And we went with an approach where we now have product teams. There's now a team who is responsible for all the peering-related stuff. There's now a team responsible for all the cloud stuff. And there's a team responsible for all the access-related stuff, so the physical stuff. And they do the whole stack. They are responsible from the beginning of the portal or the customer order until they have, we can later to that, resolved to an intent what should happen. So we organized our software also in that way. And we found out over a long time, one big monolithic system doesn't work. You can do that, you can buy that from different vendors. There's a large monster which shall do everything, but it doesn't do. It will not be flexible enough. So we said, okay, let's have a certain look forward. And then we had, okay, we want some goals. What do we want to do with our new system from what we learned over the last decade? And the first one is, we want to have an open source system. As in open, not as in free. Don't misunderstand me. We would have been happy to pay for a solution. But if the vendor just gives you a big blob, you are alone. If something goes wrong, you can open a support ticket, and if you're lucky, somebody will come back weeks later and tell you, oh yes, you did something wrong. But you can't look into the source code, you can't fix stuff yourself, or even understand stuff yourself. So we believed, if we want to have a new solution, it needs to be open. We need to have the control over the system, and we must not rely on somebody else saying, oh yes, use it as it is, and hope that our support will solve our problems. Also, we wanted to have something which is NOS independent, so the network operating system. You can get a vendor solution, and they will tell you, yes, we will support other vendors. You just need to add some plugins to that. Just write them yourself, the API is open. But if that goes wrong, which support team do you call? Do you call the vendor who gave you the system, who will tell you, yes, you're using our API wrong? Are you talking to the NOS vendor saying, hey, yes, we're sending these calls, but it's not working? They will tell you, yeah, that's no developer stuff. You can buy professional service, we will help you. So we said, okay, whatever we do, we want to be open. We want to be able to use different platforms, different versions, whatever comes around, because this is a plan for the next 10 years. We also wanted our service configuration intent-based. So what is an intent? Let me give you an example from DE-CIX. Somebody orders a peering or a connection to a peering LAN. The intent then which would go to the system would be, hey, please configure port A, VLAN ID C, this MAC address, this IP addresses are assigned to the customer, and this is his bandwidth. In an abstract way, so that the product team who is responsible for that stuff doesn't need to care how the implementation on the device looks. That's not their part. They should just say, okay, we went through the order, we did all the business stuff, but the actual implementation, I don't care. I don't care if I need to do MAC filters or IP filters or what cross policy to set. I have an intent, please do that for me, and we wanted to decouple that. Also, our base configuration must be completely generated. I believe many of you do automation. Who do full automation so that the full configuration of the device is auto-generated? I see a very few hands. That was one of our biggest goals, also to say, okay, we have this big platform, there are hundreds of routers out there. We cannot do manual configuration on all of them anymore. Also, we wanted to have some more modern features. So we said, okay, now we're doing SNMP. SNMP has many shortcomings. But one, for example, is it doesn't know about transactions. If you need to change 10 things and 2 fail, well, good luck finding out what failed and how you can fix it afterwards. So we decided to go with netconf and Yang. Netconf is a protocol which is also out there for some years now, which is enabling you to use a programmatic way to talk to your devices. And almost any vendor is already supporting that. And Yang is a description language. And also, it's a vendor-independent description language of the router configuration format. So you can check early on, hey, is my configuration really valid, at least syntactically? And we said, okay, if we can early on check that our configuration is valid, and let's say there's a field which expects an IP address and we put in a MAC address there, we want to see an early error. And that is also what went in there. And we said, okay, it needs to scale. We have a network of hundreds of routers. It will grow. And with the existing solutions, we didn't see a path forward how that can grow. Yes, of course, you can now get a VM with 128 gigs of RAM and more cores. But at some point, there will be a limit. And it doesn't go away. Also, that's something for which people hate me. We wanted to remove the administrative access from users on the routers. Some of you know me from earlier talks where I shared my desk with Christian Köntrup. And he at one time said to me, you know, if you need to use SSH, you should open a ticket because either your automation or your monitoring is broken. And that is a completely different concept than today. Today, my colleagues are going on the routers, doing manually changes if it's on the base config side, and there happen mistakes. Sometimes it's just a typo, sometimes it's something which they mangled up somewhere, which came from different systems. And we said, no, we don't want that anymore. We want that our documentation is the same as the configuration. There must be a path forward and backward. And that only works if you remove the access to the configuration. Yes, of course, there are emergency measures and stuff going on, but in the default way of working, people should not access directly on the router. We wanted to have a clear separation of concerns. So people should not be thinking about stuff they do not need to think about. If somebody is doing something on the peering side, he should not care about the backbone side. And the backbone folks should not care about the peering side. But in the existing world, if we add a new router, somebody from the peering side must say, okay, this VPLS must be on that router, and we go on there and we do stuff, and the rollout teams which we have to think about it. An absolute nightmare to do this organizationally. And we also wanted to reduce our development dependencies. So right now, in our old world, we had this big monolith of software. If the peering team changed something, the other teams can't. Or they shouldn't by our internal processes, because we have so often seen side effects if 2 people work on the same code base and do a rollout at the same time. So we asked ourselves, hey, how could an architecture look which is ready for the future? And then we came up with this architecture. There's the time. We decided on a new idea to say, okay, for every product there should be a microservice, which is managing all the details of the product. And it shouldn't matter if our customer service using our internal Artemis tool is accessing that, or if a customer, so you, are using our portal, our API, to use the same features and the same possibilities. Right now we have some stuff which you can't do as customer. You need to call us. And there's other stuff only you as customer can do, but not our customer service. If you call us, what will they do? They will go to the portal and do the same stuff you would. And that was also a certain nightmare. We also said, okay, in the existing world, everything was synchronous, which was a huge nightmare for some colleagues, because if you did a change in Artemis, you had to wait until it was done before the tool let you do something else. Sometimes you have changes which took a certain time due to the architecture, and they were blocked. We said, okay, we want to have a message bus, so it's an asynchronous communication path we have in between the different tools. So they can say, hey, I have this intent, here's the intent, and please inform me when you're done. But I'm not actively waiting or polling for that stuff. On the other side of this message bus is a network orchestrator, which takes data from what is called the service repository, which is basically all the customer-related intents are stored in there after they have been implemented, and also taking the data from our DKIM, so Netbox in this case, and pulling that together to create the full configuration of the device. And that then gets pushed out to the platform. So message buses, that is a complicated topic, and people could talk hours about it, but let's make it short. It's an asynchronous architecture. It's like a mailbox. You put something in, and at some point you can pull it out. And if it takes 2 days to pull it out, it doesn't matter. It's still in there. That gives us a non-blocking architecture, so there can be hundreds of messages, and we will work on them, but nothing is being blocked. It's decoupling our teams. This is a defined interface between different teams where intents can be exchanged. There's no, oh, we need to define a new protocol or stuff. We have used Kafka for that, and that gives us a certain flexibility between the teams. Some teams are developing their stuff in PHP, others are looking at Go, my side is working in Python, but we don't have any kind of issues there because there is a defined interface. But this is only part of the interface. The other stuff we have is an abstraction layer, which we call the product contracts. So if you have these intents, you want to send them in between the different systems. But how you define an intent and how do you check that it's valid? For that, we use the tool of API contracts, which is a definition of the API and the messages you can send. And it can show you a little bit how it looks. I brought you on the left side how a rendered contract partially looked, because I was thinking about showing you the actual source code, but forget it. You wouldn't have seen anything. And on the right side is how it would look if you would send some data. So in this, we have here a peering access service create. As I said, this is the intent. Hey, I want to have a peering access service. And it's having all the relevant data so that the technical side can create this on the platform. And it has all the data. It has a certain format. So if you would send me something where something would be missing or something would not fill the format, you would get a rejection. Hey, you're not following the contract. And this also gives us opportunities because we can upgrade a contract. We can have breaking and non-breaking changes, and teams can work differently on that. We only need to come once together to say, okay, this is a new contract version. Hey, it's a breaking thing, okay, when we need to update both sides at the same time, but we can develop independent of each other. Or if it's a non-breaking one, hey, one team can start and the other can pull on later. And that's what we have been doing for whole time now, where we always have this, okay, we need to change something, hey, let's go on. Okay, let's talk a little bit about implementation. And I have a thought for you. Your DKIM is not better than any spreadsheet. How many of you managed IP addresses or information in spreadsheets at some point in time?
At some point.
Yeah. But then we got later on and we started having tools. But are those tools better? And I say no. And I want to give you a reason for that. We have pain with data. Data is only useful if the format is known. For IP addresses, VLANs, that is very, very easy. But what about other data? Humans must be guided. If you take a tool like Netbox, you could put in your device in multiple ways. Hey, how do you model line cards? How do you model optics? How do you make sure that data fits together? If you want to automate, it always has to follow the same path. Humans must be guided to do that, and the tool doesn't do that by default. Well, the DKIM doesn't help here. It's just a tool, it's a database where you can put in your data in any way you want. So, what do we need to do? Specify how your data should look like. How is a line card modeled? How is a module on the line card modeled? How are power supplies modeled? Most people don't care about that because they say, I have my interfaces in here. I manually configured the device, everything is fine. Well, ensure that your data follow the guidelines. Yes, that take ages. But you must do that, otherwise you will not be able to configure your stuff. Well, yeah, spend weeks to fix data, and then enforce that data follows your guideline. And that's a pain point. All the DKIMs usually don't have the right tooling to do that. That's really hard coding to do all these checks, is the data following the guideline, especially if you have dependent objects. It's easy to ask, let's say, Netbox, hey, put a regex on this field. Yeah, that's easy. But can check, hey, I want to put in a 100G optic. Is this port a QSFP Plus port which has enough power? And what is with the other ports around? Do I have some kind of faceplate limits? That's really painful. Also in such projects, of course, we have a human factor. When we started this project, people were asking, why do I need to change my workflows? It's working fine. I'm doing copy and paste from my text file. Worked fine for years. It worked the last 15 years. Yes, you're right. Other people are asking, hey, if you automate that away, that's my job. Others saying, it's too complicated. Hey, I was doing my config files all the years, and now I need to use a tool? I don't want to do that. Others saying, hey, I'm the engineer. I need full control. I don't want this aid. I can do it all on my own. Others are saying, hey, I don't understand how all the parts are fitting together. And you need to handle these problems. Such a project is 90% human and politics, not technology, if you're in a larger organization. You need to start building partnerships. You need to have ambassadors. So in my team meetings, I have from all relevant teams always somebody else from the teams coming in, using our tools to see what's going on, what's being developed, because at some point you say, hey, I'm done, and they never saw it. So they can early give input. And also do early on demonstration and trainings. We always have reviews after a sprint where we talking to the people and saying, hey, I'm showing you what we have here. We have training stuff and other stuff for that. Okay, I see my time is currently running a little bit out, so I will skip some parts. Sorry for that. Come on. Let's talk a little bit about testing, because I think that's a very important topic on this stuff. People were saying, there's no way you can be sure that what you do is working. And I was like, we have 100 routers out there. Yes, of course I cannot test that. And then I said, okay, I have a shadow. So we decided to have a DE-CIX shadow. And that's a funny thing. For our NOS, a simulation framework exists. So we can simulate our routers. I think that many vendors have something like that. But usually it's not really helpful because you get some kind of virtual box which is doing stuff. We were lucky. Nokia was having a solution where you can really simulate the whole router with all its line cards, all its ports, all its stuff. So I can put in a second system which looks exactly like the real world. And yes, that's what we're doing. We are simulating the whole DE-CIX networks. Effectively, we are doing it 2 times. There's a production shadow, and there's a staging shadow. The production shadow is already running, and everything you do today on our production platform is simulated there. So I could see early on, hey, do the API calls work? Is there something going on? Is something breaking? Also, we have hard software guidelines for our stuff. We're using test-driven development. So you usually write first a test and then implement the code. We have reviews. We have massively reviews. No code goes to production if at least not 3 engineers have looked at it. And usually me, but I'm not a software human, so I'm not like, yeah, it looks good. And okay, something is weird. We have quality frameworks around. So we say, okay, whatever code goes out has to be tested, has to follow guidelines, has to have a certain cognitive quality. That is a measurement how complex certain parts of the code get, and if they get too complex, we need to change them. And we have our smoke tests, which means, okay, we test early on in our shadow, does stuff work before it goes to production? So usually, all of the stuff you would do is run once and verified against the system that it works. And of course, the shadow validation, which is running. Okay, deployments. Yes, we have deployed the first routers. 10 nodes are already managed by our software. The first adoption of a device was done in a maintenance window. All other adoptions, people were so confident they said, okay, we do it during business hours. There was no maintenance window, no announcement, we just did it. And it's fast. It takes about 10 minutes to change a router from the old way to be managed to the new one. And all the other customer-facing devices will follow next year. We will announce service windows for that because there will be some changes which are service affecting, but that's the way of life. Our results? We slashed the time for integration of new nodes radically. That was a week-long process before because every router had to be touched and managed and stuff, and it's now minutes to do that. We don't have any more incorrect configuration because some stuff was being managed manually. You don't want to know what I found out there in the production network. And we're happy it's gone. And the implementation speed. We can now do new features within days. And also the employee satisfaction is much higher because it's much easier to do stuff. Things cannot go wrong or less wrong than before. And they have the confidence, hey, I'm doing the right thing. Okay, 1 minute 30. Just one more thing. We had to add a new product at some time, and people were coming to me, hey, we have a customer, he wants to do 800G, can we do that? Yeah, sure. Well, there's no software release for that. We do not have the optics. And in 2 weeks, there's DENOG. Yeah, let's say the software release was on the last day of October, 21 o'clock, that was, I think, a Friday. They also changed the Yang models. The optic was special, and the software, we didn't get a beta which was running on our shadow. Well, I have 1 minute. Let's just say, on Friday, last week, DE-CIX is now officially supporting 800G ZR+. So 800G, single lane, single fiber support. If you have the demand for that, come to us. You can get the highest speeds at our site. And since I have 35 seconds left, I'd say we skip the Q&A. You will find me on the social. Just look for the guy with the blue hair. There's another one, I've seen him. Not him, me. And I'm happy to talk about it. And thanks, and back to you.
Tom. Maybe we have time for one question if I look at the clock. So is there somebody who urgently wants to ask something? Because if not, I have one question for you. Because we have a lot of people transitioning from more traditional artisanal networks. Where would you suggest them to start? Because this is a huge endeavor. What would be the first thing to look at?
Try it out on a greenfield. Start with something which is not important. Use some tools like container labs, and just do it.
Cool. Thank you.